Alright, let's go one step further, and in this section we're going to take a look at the quadratic, which we've dealt with quite a bit, but this one might look quite a bit different than what we've seen so far, at least on the surface. So we're going to go with e, and we're going to give it an exponent of 2x minus 3e to the x plus 2 equals 0. So again, looks a little intimidating for some of the problems, or compared to some of the problems that we've already done, until you look at this. Remember, one thing we can do is we can pull apart exponents here and make it one exponent raised to another exponent. So I can actually rewrite this first term like this: e to the x all squared. Remember, from our exponent rules, an exponent raised to an exponent, we just multiply them. So I go minus 3e to the x plus 2 equals 0. All of a sudden, we've got this one set up as a quadratic. So I can just go to factor this one, and this one actually works out nice to factor right away. So I can say e to the x times e to the x, and then I'm just going to get minus 1 and minus 2. And if you want to check that with the FOIL method, you're going to end up with this same solution up here. So, just like normal, we've been doing this before. Once we get our factor, set each factor equal to 0 and solve it. So we're going to get e to the x minus 1 equals 0. E to the x minus 2 equals 0. So over here I can add 1 to both sides, which gets me e to the x equals 1. Now again, I still have to get that x, so we're going to use some of our property work that we've been doing, and we're just going to do natural log of e to the x equals natural log of 1, again, base e and e gives me x. And again over here, natural log of 1 by one of our other properties is just 0. So there's one potential solution. This side we're going to add 2. Same step, we're going to do natural log of e to the x, natural log of 2. That just gives us x here, and on the right side I really can't simplify anything with that, so we're just going to leave it as natural log of 2. And again, this is one where you should be checking all of these, at least on your calculator. In this one it happens that both of them do work out, and we get 2 solutions. Now, we're not always going to get lucky enough on this step where it's going to come out nice, so let me show you one other option that you may deal with on this, on that line. Once we get to this step, we could end up going with a value of 1, a b value of -3, and a c value of 2, and go and write quadratic formula. And you could do that right away if you wanted to. Now in this one it just happens that the e to the x is our middle term. So instead of saying x equals, we would actually go with e to the x equals, and then go to our quadratic formula. So opposite of b, plus or minus, square root, and then b squared minus 4 times a times c, and that's going to all be over 2 times a, which in this case is 2 times 1 or 2. So if we go to simplify this one, we're going to get 3 plus or minus. Inside here, 4 times 1 times 2 is 8, 9 minus 8 is 1, square root of 1 is 1. So we get this, and simplify that into 2 separate problems. We're going to get e to the x equals 3 plus 1, which is 4. 4 divided by 2 is 2. And we're going to get 3 minus 1, which is 2. 2 divided by 2 is 1. And now we're right back to where we were down here. So obviously we're going to take this down and get the same solution. So sometimes we're going to be forced, because the factoring method's not going to work, we're going to be forced to break this down into a quadratic. This time we didn't have to, but just wanted to show you that you could end up doing that if you needed to. So something to keep in mind, and again, you can jump right to quadratic anytime you want if you feel like it. So that would be one other type where it gets to look a little ugly at first, but once you realize, oh yeah, quadratics. We've done that before. You should feel fairly comfortable with it. Alright, time to move on here. Now on this problem, we're just going to say natural log of x equals 3. Now again, we could work this one dealing with some of the properties where this is a base e, and one way that the particular book that we're using does this is they just take this and they say, alright, since that's base e, let's throw it up as an exponent. So that means I'm going to use a base e here, and I'm going to do the same thing on this side, and the only reason I want to do that is because if this base matches this base, that's my simplification, so I get x equals e to the third. And that's a good way to do it, and again I wanted to show that because that's forcing the properties, or focusing on the properties instead. The other way we've looked at a problem like this was just doing that circle method again. Natural log of x equals 3. Again, we know natural log means base 3, or base e, so we can just do the circle. E raised to the third power equals x. A little shorter this way, but again, just to focus on property here compared to shortcut over on this side. So again, that's something we can work with. What about one like this? Log base 3 of 5x minus 1 equals log base 3 of x plus 7. Alright, so let's take a look at this one. This one we can go right to our properties again for 1 to 1 because it's a log base 3 and a log base 3, which tells me that this and this in the parentheses have to equal each other. So we'll drop those down to the next line. 5x minus 1 equals x plus 7. And this looks like some basic stuff that we've done for quite a while. So let's subtract x from both sides to cancel the letters on the right side. And let's add 1 on both sides to cancel the numbers on the left side. So this is going to leave us with 4x on the left, 8 on the right. And then I can divide by 4, and I can divide by 4. And I'm just going to get x equals 2. Now again, pretty simple work. Simple one to check as well. If I put 2 back in for x, 5 times 2 is 10, 10 minus 1 is 9, so log base 3 of 9. On this side, 2 plus 7 is 9, so again, log base 3 of 9, it works. We've got our solution. So there's our one-to-one property working for us. Now let's try another one where there's a few extra terms involved compared to the one that we just looked at here. And it's going to look like this. We're going to go log base 6 of 3x plus 14. We're going to subtract log base 6 of 5. And we're going to set that equal to log base 6 of 2x. Alright, a little more complicated as far as more terms here, but this is where we can start applying some of the things that we've already worked with. So on this one, we're going to use our quotient property, which says I've got a log base 6, subtracting a log base 6, I can combine these into a single logarithm base 6. And again, remember subtraction goes with division, so that means I'm going to get 3x plus 3x plus 14 all over 5 on the right or left side. We're going to leave the right side alone. Nothing I can really do with it anyway yet. And now we've got a one-to-one situation again. Log base 6 means this is going to be equal to this. So let's set that up. So 3x plus 14 over 5 equals 2x. I can multiply both sides by 5, and that's going to cancel this. We're going to be left with 3x plus 14 equals 10x. And then I can subtract the 3x over to the right side, and I get 7x equals 14. Divide both sides by 7, and I'm going to get x equals 2. Now again, we probably should check this. If I get 2 here. 3 times 2 is 6, plus 14 is 20. So if we did 20 divided by 5 in our quotient rule, I'm going to get 4 over here. 2 times 2 is 4. It works out. There's our solution. So again, especially the more involved these get, you definitely want to keep track of your check and see, does it work or does it not work? So that's where we're going with that one. Let's look at one more problem I think we got time for in this video. So on this problem, let's look at this. 5 plus 2 times the natural log of x, and that got a little messy. Natural log of x equals 4. So again, we're going to go back to simple algebra. We're going to isolate by subtracting 5 on both sides. So this goes away. We get 2 times natural log of x equals negative 1. I'm going to divide both sides by 2. So now I have natural log of x equals negative 1/2. And again, here's where we could either invoke one of the properties or we can do our shortcut, which is what I'm going to do. Since natural log is base e, I'm going to do circle. So we're going to get e to the negative 1/2 is actually equal to x. And again, depending on how we want to set this up, I'm going to go one step further with this. I don't want to leave with that exponent being negative, so we're going to do reciprocal. 1 over e to the 1/2 equals x. And again, 1/2 is actually the same as their square root. Now, depending again on where we want to actually go with this problem, we could rationalize this fraction so the denominator doesn't have a radical in it. For the sake of our problem here, I'm just going to leave it. And again, there's a possible solution. Make sure you check it at least by sticking this into your calculator and seeing, does our left side actually end up equaling our right side.